Today we're going to look at some specific problems. My advice might be to pause the video, try to solve the two problems, and then run the video to see if you got the same answer. There are lots of ways to approach simplifying exponential expressions. I'm just going to talk through the way I would do this. Okay, so for our first problem, we have y to the negative eighth times y to the fifth times y to the negative second. And in this case, because I have the same base, I'm going to add my exponents and get y to the negative 8 plus 5, negative 3, minus 2, negative 5, and then simplify my answer as 1 over y to the fifth. Okay. In this case, I have the same base in a division problem. And because my exponents aren't both positive, I'm not going to use my canceling strategy. I'm actually going to do this as x to the 3 minus negative 3 power. So that's going to be x to the 3 plus 3 sixth power. That would be the answer to this one. Okay, here's another problem for us. I have a power that needs to distribute to every piece of this. So I'm actually going to do that first rather than simplify what's inside the parentheses. So I'm going to get p to the negative fourth to the negative third, which becomes p to the 12th. And so the advantage is it's going to stay right there. Q to the first raised to the negative third, so q to the negative third, r to the negative third raised to the negative third, so r to the ninth. By using the power of a power rule first, I notice that two of these things get to stay. P to the 12th is already where it belongs. R to the ninth is already where it belongs. It's just the q to the negative third, which should actually be in the reciprocal spot, which would be the denominator in this case. Okay, so I have to do the exponent first before I can think about the common base of m. So I'm going to get m to the 16th, n to the negative 8th, over m to the negative 2nd, n to the 5th. And again, even though I have the same base, because the exponents aren't both positive, I'm sort of thwarted in my love of canceling. So I have to use m to the 16 minus negative 2. So m to the 16 plus 2 would be m to the 18th. N to the negative 8 minus 5. So n to the negative 13th. And that's going to say the m to the 18th will stay, and the n to the 13th belongs in the denominator. Okay, here again I have a power and all these different components inside. I could simplify the inside because I have things to the same base, or I could do the power first. I tend to do the power first. I don't know why. So I've got 4 to the negative 2nd, x to the negative 2nd, y to the negative 4th, over x to the positive 2nd, y to the negative 2nd. 4 to the negative 2nd doesn't have anything that it's going with, but it belongs as 4 to the 2nd in the denominator, which I'm going to call 16. X to the negative 2nd, x to the 2nd. So x to the negative 2 minus 2 would be x to the negative 4th. Y to the negative 4th minus negative 2. So negative 4 minus negative 2 would be y to the negative 2nd. That means 16 stays here, x to the fourth is here, y to the second is here, and my numerator was empty, so I filled it with a 1. Okay, here I have 10y and 10y, same base, so I can add my exponents, 10y to the 9 plus negative 8, so this is just 10y. Wow, lots going on here. Okay, so I have 7 to the negative first to the negative second. So 7 to the second. X to the negative third to the negative second. So x to the positive sixth. X to the fourth to the negative sixth. So x to the negative 24th. And then my denominator, 7 to the negative first, x to the negative third. 7 to the second, 7 to the negative first. So 7 to the 2 minus negative 1. So 7 to the third. X to the, wow, I got a lot of x's. Let me put the ones on the top together first. So this would be x to the negative 18th. I still have my x to the negative third down here. So I'm going to get 7 to the third. 343, I think, but that's just a guess. X to the negative 18 minus negative 3. So that would be x to the negative 15th. So my final answer is going to be 343 over x to the 15th. Okay. 8pq to the negative second is not the same as 8p to the negative second q to the negative third. So I don't have the same base, so I can't just subtract my exponents. I have to tackle this one piece at a time. So I've got 8 to the fourth, p to the fourth, q to the negative eighth. I've got 8 to the third, p to the negative sixth, q to the negative ninth. Okay, so I've got 8 to the fourth and 8 to the third. These are both positive, so if I can use my canceling strategy, 4 factors of 8, 3 factors of 8, that's just 1 factor of 8 left. P to the 4 minus negative 6, so p to the 10th. Q to the negative 8 minus negative 9, so q to the first. So that's it. Everybody's in the right spot. Okay, that's it. Problems tomorrow are going to require great focus, so have a good breakfast.